So let's go fast. Define the following terms. I'm going to tell you right now, 4 of these are on your test. So make sure you can define these terms. Remember, I'm on page 124. Remember that the wave-particle duality is that light and subatomic particles seem to behave both as particles and waves, that the Aufbau principle was just that the electrons fill the lower orbitals and the lowest energy first and then go to the higher ones. Valence electrons are just the outermost electrons, and when we get later along, basically they're the electrons in the highest number energy level. That's what the valence electrons are. Okay, you can think of them right now as the outermost electrons, but they're the ones in the highest number energy level. And then, let's see, ions are just atoms or groups of atoms with a charge. You can remember it that way. Ionic compounds are made up of anions and cations. In other words, when ions get together and transfer electrons, that makes ionic compounds. Electrolysis is to break down a chemical with electricity, and electrolytes are just things that conduct electricity when dissolved. That's it. Number 2. What do we call the current model of the atom? What is it, guys? You tell me. Quantum mechanical model. Very good. Number 3, when waves overlap, so their crests get higher and their troughs get lower, what is that called?
Constructive interference.
Very good. Constructive interference. What's the opposite of that? Destructive interference. Gosh, that sounds like my little brother. Anyway, sorry. I have a little brother. He's now huge, like Arnold. Okay. Yeah, with the babies. Number 5, fill in the blank. In order to come up with his model of the atom, Erwin Schrödinger analyzed the electrons as if they were waves. Okay. Number 6, list all the orbitals available to electrons in the 3rd energy level of the atom. Indicate how each orbit type exists. In other words, what electrons are in the 3rd energy level? So, Sean, what are these called in this group? S, P, or D? S. So he's asking, in the 3rd energy level, we would have an S orbital, we would have P orbitals, right? 3 P orbitals. And then we actually, in the 3, would also have the 3 D orbitals, which we'd have 5 of those, correct? Okay. So when you answer this question, you would say 1 S orbital, 3 P orbitals, and 5 D orbitals. I'm sorry?
We're only 5.
D orbitals, there's 10 of them, so there's 5 orbitals, because there's 2 in each orbital.
Oh, yeah.
Okay? Okay. Let's see. How many electrons can a single orbital hold? You guys tell me. 2. Very good. One of the following orbitals represents a 2p orbital. The other represents a 3p orbital. Indicate which one represents which. So what'd you get there? B is the 2p and D is the 3p. Also, you need to know the shape of the s orbitals. Which ones of those are s orbitals? A and C. Very good. Number 9. Sunshine from a pinhole is shined on 2 small slits that are very closely spaced. Which of the following is the result? So what'd you put for that? B. Very good. Because of the destructive and constructive interference, that's what we would see. Number 10. If electrons were used in number 9 instead of light, which of the 2 patterns shown in number 9 would you produce? No, it would still be B, because they act as waves and particles, remember? So it would still be B. Be aware of that. Okay, number 11. You've got your periodic chart in front of you. It's shaped something like this, so I just want to show you. Nitrogen, if you find it on your chart, it's number 7. It's like right about here. So you're going to go 1, S2, and you come down to the 2nd level. So there's 1, there's 2, there's 3. 2, going to get across here, S2. And then you're over here, 2p, and you count into the nitrogen, 1, 2, 3, so it's 2p3. And that's how you do it. The next one is aluminum. Aluminum is right here. So we're going to go back up to the top, 1s2. Now we're going to go to the 2nd level. I'm just going to make it so you can see it better, I hope. 2s2. 2p6, because we went all the way across. Remember, there's 6 spaces there. Now we're down here, 3s2. And we're right there in the 3p, but there's only one, so it's going to be a 3p1. Okay, next one at S is magnesium. Magnesium is right here in the 3rd level. So we're going to do it again. We're going to go 1s2. We're going to be here, 2s2, 2p6. Now we're over here, so we're going to go down here. 3s12. And we're at magnesium. So that would be its electron configuration. Number 12, if we were doing the abbreviated ground state for iodine, which is here, you go up to here, 1 back, the noble gas behind it, and you do Kr. And then iodine's here, so we're going to go down here and go 5s2. Then we're going to go 4d10, 5p, 1, 2, 3, 4, 5. How we doing? Okay? Let's see. Number 13, what is wrong with the following electron configuration? And if you look at it, 1s2, 2s2, 2p4, 3s2, there has to be 6 in there because of the Aufbau principle before it would go up. So you would circle that one. It doesn't have enough electrons in it. On B, if you go through it and you get to the 3p6, then it should be 4s2 before we get to the 3d10. So that's out of order. And then on C, the 2s4 should be a 2s2 because s orbitals can only hold 2, correct? Did everybody get those? Were you able to see those? Sean, are we okay on those? Okay. All right, number 14. What element has this electron configuration? And you're looking for 4p2. So you know what I'm going to do? I'm going to go right to here to 4. And I'm going to go right to here to p. And 4p2 is right there, isn't it? So that's how you find it. Just look at the last guy. It's 4p2. Just go to 4p2 and he's right there. I'm sorry?
Yeah.
You got that one? That's pretty nice, isn't it? I love this, the way he teaches this. So once you get it, it's like, oh. I told you, though, it's not something you can get at home very easily. You got to be standing up here going back and forth on the big thing, and then it makes more sense. Okay, let's see. Number 15. What do we call the elements in group A on the periodic chart? What do we call them? Noble gases. Very good. Which of the following elements should have very similar behaviors, chemical behaviors? Now we're looking for two that are in the same group. And we're looking for 2 in the same group because remember, if they have the same number of valence electrons, then they're going to act similarly. The 2 in the same group there would be aluminum and this one. Okay? And so those would be the 2 you picked. Draw the Lewis structure for oxygen. Oxygen is in group 6A. So oxygen would be 1, 2, 3, 4, 5, 6. Okay? And then it says to draw the oxygen ion and give its name. Well, this guy is going to want 2 electrons. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8. But now that he's gained 2, it's going to be a -2, and that's the oxide ion. If some of this you're still struggling with, it's okay. It's new, but you're going to get it. Can you follow it as I do it? Can you follow it as I do it? You'll get it then. We just need to practice, okay? Draw the Lewis structure for the ion. I'm on number 19 for potassium. And what's its new name? Potassium is in group 1. It's K. So if it loses its 1, what's it going to do? What charge is it going to have? It's going to be a +1. It's going to give it up. And so that's just called the potassium ion. It's not named anything new. Just you throw the ion on the end. Number 20, name the 3 properties of metals and compare them to the relevant properties of nonmetals. He wants to know that metals are shiny, bendable, and conduct electricity, and nonmetals don't. Okay. Number 21, what are the chemical formulas of the compounds formed with the following? Okay, so we have rubidium and oxygen. Once again, rubidium is 5. You see it down there? And it's in group 1 on the 5th level. So what's its charge going to be? +1. What about oxygen? What's its charge going to be? -2. So we're going to flip-flop. This comes down here, and that is going to be rubidium oxide. Okay, you got to be able to do this like forever. SR and sulfur. So we go SR. SR is right there in group 2. So what's its charge going to be? 2 plus. Very good. And then sulfur is right here. What's its charge going to be? -2. And so you just take them away. And that's going to be strontium, I think that's what that is, but I'm not even sure, but SR sulfide. Does it say to name them? No. Good. Calcium, nitrogen. Okay, so let's do calcium and nitrogen. Calcium, what's its charge going to be? It's over there, Ca. Right? Okay, and then it's paired with nitrogen. What's its charge going to be? Good, -3, flip-flop. So this one gets the 3, this one gets the 2. Take away the charges, and that's calcium nitride. And then the last one, magnesium and and iodine. Magnesium is right here. What's its charge going to be? Good. And then what about iodine? -1. So we flip-flop. So this one gets the 2, and that would be it. You'd be done there. Okay, let's see. What is the chemical formula for calcium fluoride? So you'd look over there, and what's its symbol? Calcium. Ca. And what is it? +2. And then here's fluoride. What's its number? Its charge? -1, right? Okay, so we flip-flop. This gets a 1, this gets a 2. And there's calcium fluoride. You've got to be able to do that for this test and forevermore. Nitrogen and hydrogen. And it says, nitrogen and hydrogen react to form a compound. Is it ionic? Is nitrogen a chemical? I mean a metal? No. And even though hydrogen's over there, it's not a metal. Remember, it's a nonmetal stuck over there. It's because it's in group 1 because it tends to give away 1 electron. Let's see. 24, yeah, it likes to share. What is the chemical formula for iron 3 oxide? So what's the charge going to be on iron 3? They tell you guys, what's the charge on iron 3? +3, right? And oxide is -2. So you put the 2 here, you put the 3 there, and that he's going to make you go backwards on the test. You got to be able to go backwards on that. He would ask you what's the name of that, and he'll tell you that iron is a transition metal. So you have to be able to look at this and go, okay, well, from this, what's the charge going to be? Well, I know this charge is going to be -2, so for this to be true, this would have to be a +3, which means that had to be iron 3 oxide. You have to be able to do that for your test. Okay? Got to go backwards. Let's see. 5, chromium can take on more than 1 charge in an ionic compound. Okay, so that means you've got to put the Roman numeral there. What is the name, there it is, of chromium chloride? So you have Cr and you have Cl3. Now you know this is a -1, which means this guy has to be a +3, doesn't it? So the answer is chromium 3 chloride. 26, which of the following compounds, when dissolved in water, is likely to produce a solution that does not conduct electricity? We'll look at who has a metal, because if they got a metal up front, they're going to conduct electricity. So which one doesn't have a metal up front? C, right? So C would be the answer there. If you wanted one that does conduct electricity, then the answer would be any of the other 3.